Good morning. I'm surprised, second talk after the party, still a lot of people here. Well done. Welcome to my talk, Keeping Developers Happy with a Fast CI. My name is Christian Bruckmayer. You can find me on Twitter at Bruckmayer, and on my website, bruckmayer.net, where I will also upload the slides. So if you want to have a look later, it's all on my website. Today, I brought a few different topics. I will start with a quick overview about CI and our team and what are we doing. Then I will talk about data-driven development. And then I brought three different topics: test optimization and test selection, what we do already, and test prioritization, some experiments we did recently. So let's start. I work at Shopify. Shopify is one of the oldest and biggest race applications out there. It's an e-commerce solution. We have a big booth over there, so if you want to chat to some people from Shopify, then please come over. I work in a team called Test Infrastructure, and a lot of people always ask me, test infrastructure, is that quality assurance? No. So our team mission is ensure that our CI systems are scalable, robust, and usable, with an emphasis on our Rails monolith. And you're probably wondering, a team? I worked at companies before, and CI was always somebody worked for an hour here and there if something was broken or needed to be improved, but there was never a dedicated team or a dedicated person working on this. And the reason why we have a dedicated team is just of the scale of Shopify. So the Rails core monolith had 2.8 million lines of code, over 1,000 engineers work on it, and in terms of testing, we have 210,000 Ruby tests. If you would execute them, it would take around 40 hours. We run around 1,000 builds per day, which means we run around 100 million test runs per day. So that's a lot. So that is our biggest problem is growth. So growth in terms of tests, because we add around 30% more tests every year. So sometime next year we will have 260, 270,000 tests. And growth also in terms of people, because we're hiring this year 2,000 engineers. So that's basically doubling our engineering size. And it comes with lots of problems. We will run more builds, more commits, more tests. And that's the reason why we have a team. Our mission is to spoil our devs, to make them happy and provide the best tools we can. The first topic I want to talk about is data-driven development. Data-driven means progress in activities compelled by data rather than by intuition or by personal experience. And that is what our team does a lot. We measure everything. So we have insights into every single build, job, test, command, what runs in CI. And before I can go into it, how we do that, a quick overview about our CI, which runs on buildkite, which is our the web front end, where the builds and the jobs run. And then we have different test agents which execute the tests, and these are running on premises in our Google Kubernetes cloud. And the big advantage is that we can scale them on demand automatically. So at night, we would scale it down to almost 0 agents, and then in the morning when people start working, we scale them up and have thousands of agents. And this is how a typical build looks in buildkite. So the top idea is you have a build. A build can have several jobs, and the idea behind a job is that you can parallelize things. So you can run several jobs which would all execute tests in parallel. And each job has several commands, and a command could be bundle install or just executing a test. So instrumenting jobs and builds is quite straightforward because buildkite offers webhooks, and we just have a small Rails application which listens to these webhooks. And if a job finished or build finished, we receive this webhook and we stream it to Kafka. And eventually it would end up in our data warehouse where we can select jobs and build finished, and we can run reports and would see a distribution of job and build time. And that really helps with, like, we see where a problem is, but you don't really know where the problem is. So to understand where problems are, we need to really drill down to a command or to each single test. So every single command we run in CI gets run in a little wrapper. So we measure the time, and then we also stream it to Kafka. And for tests, we get a JUnit report, and it also gets sent to Kafka. And eventually, it ends up in our data warehouse, and we can, like, we know how long it takes bundle install, how long it takes one single test. And then we can set priorities, like we know how often a command gets executed, how long it takes, and then we can plot, for instance, count over the duration, and then top right corner would be our highest priority tasks, which take a long time, get executed a lot. And that really helps us with setting priorities, and it even helps with driving projects. So last year, we started a project to improve our P95 because we saw in our data that it was getting slower and slower, and it was like our P95 was around 45 minutes to run tests in CI. The next topic I want to go into is test optimization. And test optimization is difficult if you have so many tests. Like our team, we can't go in and like improve single tests. That doesn't really work. So what we need to do is we need to look at the whole test suite. And then in this example, we see, for instance, we have clusters at the 42 minutes. So what we did is we just every day we looked at our slowest builds and tried to find a pattern. And very, very quickly we found a pattern of timeouts. In Build Guide, you can set on each job a timeout that if a command hangs or a test hangs, it would, after 30 minutes, the job gets killed and it wouldn't run forever. So what we saw is that some tests seemed to hang and caused 30-minute timeouts. So that was the reason for this cluster around 40 minutes, because it was always hanging for 30 minutes, needed to start a new job, and then it was always at 40 minutes. So one of the first things we did is wrapping every single test in a timeout, so it would get killed. The problem with Ruby's timeout is it's not very reliable because it just spins up a thread, and if you hit a timeout, it just raises an exception in your parent thread. And that can cause like undefined behavior in different libraries. Some libraries even ignore it, like MySQL just ignores timeouts. So what we did is we just skipped tests. And we notified the people working in this area of the code. They have a dashboard and see there are skipped tests. And we said, like, your test is causing the test suite to be slow. So that was our build time distribution. And we disabled around 10 tests, around of the 210,000 tests, and that was after. So we improved over 10 minutes just by disabling 10 tests. And that was happened frequently. Or not frequently, like every few months, we had a test which was hanging. So we implemented a more aggressive timeout, which spins up a thread and then kills the whole process and not just raises an exception, which still kills our job, but it would not take 30 minutes. So the idea is like, we can't optimize tests, we need to look at the whole test suite. And then interesting thing, what we learned is like, there's this 80-20 rule that 80% of, or 20% of the input cause 80% of the output. And in our case, it's more like 99-1. Like we disabled 10 tests and improved 30% of our CI system. And I guess it's very similar for, if you look at your test suite, that there are some tests in there which make your whole test suite slow. The second topic I want to talk about is test selection. And test selection is, imagine you have your whole test suite of 200,000 tests, and you send a pull request, and you only look at the changes of your pull request, and then you select some tests out of your whole test suite which are relevant to your changes, and then you only execute this. There are a number of reasons why we do this. The more obvious one is the number of like tests, and if you run less tests, it's faster, obviously. The other reason is stability, and stability in terms of our CI system as a whole, because we run
thousands of machines, and if we can run less machines, it just improves our stability. It's less likely that there's a broken node. It's less likely that there are like problems in our distributed system. And the other reason is flaky tests. If you have a flaky test which fails 50% of the time, and you run it every time, 50% of your builds will fail. So if we select less tests, it's less likely that you have a flaky test in your whole test suite. And how we do this, it's 2 steps. So the first step is we need to generate a mapping from each file to a test you have to run, or to the test file. And we generate this mapping every time we merge to the main branch, because it takes a lot of time. It takes around like 1 hour. And then on each pull request, we would use this mapping and select the tests which are relevant to the changes. And to generate the mapping, we have different strategies. And the reason for these strategies is there in your app are many different files, and each file needs a different strategy. You have like Ruby files, you have fixtures, translations, configurations, JavaScript. Each of these files needs to handle differently. So we have a different strategy for each of them. And one of the more interesting ones is the Ruby strategy, Ruby files. Because Ruby is a dynamic language. There's lots of meta programming. So we implemented it with a dynamic analysis. So we need to execute the code to generate our mapping. And we use a gem called rotoscope, which is a Ruby tracer. And we combine this with a mini-test reporter. So a mini-test reporter offers hooks into your test suite. So you can execute code before and after tests, and before your test suite and after your test suite. So we combine this with rotoscope. We initialize it at the beginning of our test suite. Before each test, we start tracing. And after each test, we stop the tracing and we write it to a file, the trace. So we know which test accessed which files. And the output would look something like this. So we have a test name, class test method. We know the file, and then we get a list of Ruby files this test executed. And we can so we get many of these output files, and then we do a processing of all these files and generate a reverse mapping. And the reverse mapping the file structure would look very, very similar to your application. So there would be, for instance, an app models directory, and there would be an app models class RB or app models foobar RB. The only difference is there's a txt extension. So if you look into these files, you would just get the list of the tests you have to execute. And in our pull request, we just do a git diff and get the files which you changed in the pull request, and then we would look into these mapping and know exactly which tests we have to execute. Another strategy which we implemented is fixtures. And we use active support notifications for this. So active support notifications is a Rails framework, and it offers hooks into the framework. So there are over 50 different hooks which you can subscribe to, and then you get a callback. And one is, for instance, SQL Active Record. So every time an SQL query gets executed, you can receive a callback. So we also implemented a mini-test reporter for this, and in our initialize, we subscribe to these SQL notifications, and then before and after each test, we just write it down and generate a mapping to fixture files to tests. So if you change a fixture file, we would only run the tests which actually access these tables. And it's not perfect, but it's a very good approximation, and it works very well. So this whole system is in production for now almost 2 years, and on average, we only select 40% of our tests. In numbers, that means instead of 210,000 tests, on average, we only run 85,000 tests, which is like a huge improvement. The last topic I brought today is test prioritization. So what is test prioritization? If you think about your test suite, you execute your tests to get confidence about your changes. And you do some changes, and then you start with no confidence it will work, and then you execute tests over time. And at the end, you're confident that nothing broke and it works. That's the expectation. In reality, it's not really true, right? Like, you don't start with zero confidence. You still have, depending on the change, you still have a little bit of confidence. And then you execute your tests, and at the end, you never reach 100%. Maybe you reach 80, 90, depends on like your test suite and how much code is covered, but you will never reach 100%. And then it's not linear, right? It's in this graph, the assumption is every test adds the same value. But that's also not true. Like, not every test has the same value. Some tests cover more code. You have integration tests, which maybe add more value than a unit test. So our idea was we would find out which tests have the most value, and then we shift them to the front, and we just execute them first. And when we executed all these more valuable tests, at some point we would reach a point where if we execute more tests, it wouldn't really like bring much more confidence. So we could maybe stop after 50% of the tests that we say that is enough confidence. If we execute now 50% more, we would only get, I don't know, 3% more coverage. So it's not really worth it. So that is the idea. So we came up with 6 different prioritizations. The default one is random. That is what we do in production. We just shuffle the tests. Failure rate is we would calculate how often a test fails and calculate a percentage, because what is the point in executing evergreen tests? Like, we have a lot of tests which never failed in the last 6 months. Maybe we can just like get rid of them. Complexity and churn is often used together. Like, that is your danger zone in the app. Files which have a lot of code in there, are complex and which change a lot. So we calculated the complexity and churn, and which test executes this area of the app. We calculated coverage of each test, like how many lines of code a test covers, and average duration is just like how long does a test take. So the idea was executing tests which are fast first. So we came up with this prioritization, and then we needed to think about how do we compare these 6 different things. What we did is we just looked at our CI, and every time a build failed, we knew like this is a bad commit, and we were just interested in finding failures first or finding failures really quick. So we took these bad commits and then executed each, like the same commit 6 times with different prioritization. And each of these prioritizations would then print out a number. And would, like in this example, complexity would be 0.8, so it's better than random and churn. And then we could compare them. So some of the metrics we looked at is time to first failure. That is, how long does it take to find the first failing test in our test suite? And this graph is called a box plot. So you can see the distribution of values. And the green line in the middle, that's the median. So interestingly, random was the best. So we find around after 2 minutes, we find the first failures. The black one at the bottom, that's the minimum. The top one is the maximum, and then the little dots are the outliers. So very interesting. Random was the best to find, to prioritize and find tests which fail. We also looked at different metrics. So our idea was, how can we find the point where we can stop? And what we came up with, it's from a very interesting paper. I put it in the bottom if you want to read it up. So like we calculated the percentage of test failures we found. So if a commit has 10 test failures, then we would calculate after 10% of the tests we executed, how many failures did we found. And we would calculate this for like 10% of the tests, 20, 30, and then we could print it out like this. And it's interesting, like random is almost linear on median. Like after 50% of the tests executed, we find 50% of the tests. And the best prioritization we found is failure rate, which makes sense. But it's not outperforming random. Like it's not, we say, oh wow, this is incredible. And on P95, it's even more like visible. We need to execute at least 80% of our test suite to find a significant amount of test failures. So that was, it was an interesting learning. And so we found out it's really hard to find all tests, or like prioritize in a way that we find all tests quickly, which we want to do in CI. When you push your code, you want to not see like one failure and then push again, see the next failure. You want to see all of them. But for other scenarios like deployment, it doesn't really matter. Like you just want to find one failure to say like this is a bad commit or this is a good commit. So for deployment, that could be interesting to just run 2 minutes of test. If you don't find a failure, it's unlikely you will find one later on, and you can just go and deploy. You don't need to wait 20 minutes or 50 minutes to run the whole test suite. And it was just an experiment. We spent like 4 weeks to just look into it. Like we're not planning to roll this out. So it was just to improve our mental model and like learn new things and get the insights. And maybe that's something in like a year's time to come back. Yeah, today I showed you 5 different topics. I was thinking about my conclusion because it was different things what we do. And like one thing is Rome wasn't built in a day, right? This evolved over the last 6-7 years. So I'm at Shopify 1.5 years. And I think the first 6 months were just like, that's an interesting way to do this. Like this was evolving over a long time, and like a lot of different people contributed ideas and code, and yeah. And the main difference, what we do compared to previous jobs I worked at, is like we treat our CI as production. Like we do a lot of things which are very normal for a production app. Like we run experiments. That's normal if you work on an app. We do load testing. Like every couple of months we look like what would happen if we have twice as many builds. And we do a lot of data-driven development. Like we collect data about almost anything, so we have insights what's going on in our CI systems. And that's also normal for a production app. Like you know how long a request takes. And if you do all these things, your colleagues will thank you and they will be happy. Yeah. We have 5 minutes left, so if somebody has questions, I'm happy to answer questions. So the first question was, what happens if a bug goes to production, right?
Yeah, if CI misses a bug because of the optimization.
Yeah, that can happen. It happens rarely. So what we found out is if there's like a failing test which goes, which we only determine after merging, because that's when we run the whole test suite. Most of the time, it's not that the app is broken, but the test is broken. And what we do is we have a stabilization build, which runs after you merge. We run all tests, and because when we ship to production, we merge like 10, 15 commits together. So it's really hard to figure out which one is the problematic one. So what we do is we run all tests again. And if there's a failure, then we just run for each of these commits the tests again, so we would figure out which introduced the test failure. But most of the time, the test is the problem and not the app code. The second one was like if we can open source this. Yes, yeah, it is a lot of customization. Like the goal, or one goal of our team is to like generalize some stuff, because we have a lot of different Rails apps at Shopify. Like we have the core monolith, but we have like hundreds of other apps, and they can't use stuff what we do just in core. So one goal is definitely like, how can we make this, like generalize it so that other apps can benefit it, and then it would maybe something we can open source. But at the moment, it wouldn't be very useful to most people, because it's just too custom. Yeah, so the question was, how do we deal with the memory overhead? We just increase the memory. So yeah, we can increase the memory of each job like agent which executes the test, because it is so customized that we can, like, we run the machines, we can decide how much memory a agent gets. But it's not terrible. It's like maybe twice as much. So the question was which tools we use for like this measuring and metrics. That's all like customized. For instance, shop and builds, we just use like the webhooks we receive from BuildKite, and then for tests, it's basically like a JUnit report which we pass and then just upload it to Kafka, and then like we get the Kafka events. For the single commands, we wrote like this little wrapper where it's just a bash script basically, that every command you execute gets wrapped in like measured the time, and then we send it also to Kafka. So it's nothing really fancy. It's quite, I would say, relatively simple, because like we just get this for test, like JUnit report is and already has timing in there, and then you just pass it and like put it in a different format. Yeah. Thank you.